Hey Rob.
Hey, how's it going? Can you hear me? Can you hear me?
Yeah, now I can hear you.
Um, yeah, I feel like it's probably just gonna be us. Um, I saw that you opened that PR. Maybe you can walk me through it a little bit. I haven't had a
Sure.
chance to really look at it yet.
Yeah, yeah, sure. So so let's see if I can trying to think where the best way would be. So first of all, it's a big diff. So it's a lot to so I called it like a rewrite. I'm not sure if not everything was rewritten, but but it definitely touched a lot of the code. So just wondering if the best would be to. So I don't think the diff is so useful. So I think maybe if I just share my screen from the like the actual implementation, that might be more useful. What do you think?
Sure.
Like, yeah. So let's see. So I'm just gonna share my editor, I guess. Let's see. So so basically, and there's two bits actually that basically, what this PR does is it follows the suggestion of the specification edits that I made in that separate PR. And like Benji's PR, what that means is that we're collecting things to be executed later, whether we're calling, whether we save the data or the actual like future executions, which is what my model does. But we save that along with the result, so that when that gets nulled, we don't have to do any filtering, and it just automatically gets dropped. Um, Now that I implemented, I'm going to roll back one commit because I actually implemented what I think is an optimization for the non-defer case, but I'm going to just roll it back one commit of what I show you so that without that optimization, so that we see a little bit closer to the to the new algorithm. So I'm just doing that now. Commit. You don't see what you can't see what I'm doing, right? You can see just okay, great. So I rolled back that one commit. Okay, so the first of all, what that means is basically I implemented a new structure called um, the GraphQL result. And and what that does is this is not the type, this is just where it's being used. And what that does is it basically saves the results at the current level of whatever processing we're doing, and whatever future executions are saved along with this. And so, once we see that like a field execution, like in execute, uh, returns, it no longer just returns, well, these are going to be littered all over. But like completing an object value, it returns now the return type. It could either return just a map, or it could return a GraphQL result, which has a result, but it also has like all the different futures that are meaning. And by future here we mean like a deferred execution that's been teed up, or a stream completion of additional streamed items. So that is now returned by the execution value. So this basically gets rid of the problem of filtering. When we're talking about filtering, we want to what I mean here in this particular case is like, let's say we tee up a deferred field, but our initial query, because of null bubbling, ends up throwing. So what used to happen was that we had to manually like go back and filter. But what's now going to happen is that that GraphQL result object will never be returned because of the null bubbling. And so those futures that were, teed up, meaning even if we initiated early execution, will never be returned when the initial object is returned. And so that's basically what this rewrite is mostly about. Is mostly about getting rid of filtering and making filtering sort of emerge naturally from the algorithm, even though we can have early execution. And that's so basically what that means is that our results, when we finish getting it, so that would be in the code base, that's in something called this execute operation. This execute operation function. So first of all, it means that at every layer we have to copy those futures into the higher layers futures, and so that we have a lot of these helper functions like handle, GraphQL result, and all these different things. But the basic idea is that when we finish, let's see, find it over here. Right. When we finish, we call this function called build data response, and then it sees if it actually has a GraphQL result. And the idea is that if we never triggered any futures, we just return that original result. So it was always a union of object map versus GraphQL result of object map, or the execute field function is just going to be like an unknown versus like a GraphQL result of an unknown. But a list would be an array or a GraphQL result of an array. But the idea is that eventually if we don't have a GraphQL result, it means we don't have an incremental response, and then we just return the original bit, pre-incremental delivery, either errors or errors in data. But if we do have a GraphQL result, that's when we call this build incremental response function. So that's defined in this other file, along with the GraphQL result, this incremental delivery file. And it used to be that the incremental publisher had to like be passed around, and we were constantly notifying the publisher whether something happened or whether something didn't happen. But now we don't have to do that. Now the incremental publisher and all of the is just processing what that GraphQL result that's been returned. And so these files, have sort of been disconnected from each other. The GraphQL result itself could be like extracted to a different file even, and then there really should be no like interdependencies on these different files, which is a nice result of that. And so basically the publisher follows the algorithm that I'll if it's helpful at all to have it up, I can just dump it into the chat also. This is it's the chat. So it follows basically the steps in that algorithm, and the first thing that it does is it basically does only two things actually. It adds the futures to a graph that it's building up of some deferred so the futures again are the future executions, and there's two types of those. We were in the previous version we were calling those incremental data records, and that's basically what's going to show up in the incremental array according to the new response format. And so those could be parts of deferred fragments, the parts that are shared or the parts that are unique as it's broken up into different parts, with several of these group field sets completing one deferred fragment, or a set of stream items. And so that basically exactly what we used to be calling incremental data records. And so at this point, we add it to the graph. That's the first step. And by the graph, I mean there's going to be a set of deferred fragments that are ready to go, because some of those futures will be like child fragments of the initial result. But some of those future executions at the same level that might be children of those initial deferred fragments, meaning nested deferred fragments. And so really they are futures that belong to deferred fragments that are nested and are not yet ready to actually be sent. So when we say what this function calls add futures, it's going to set up, it's going to keep track of all of those things, and add them to the graph in the way that I'm going to show. And then the next step is called prune empty. It just gets rid of
So
all the
how do you associate the future with a deferred fragment?
Um, so when we create the future, we save a reference to all the deferred fragments that are created. So let's go back, I guess, to where those are created, just to make sure that that's clear. So basically, this is the execute deferred group field set. So as part of this PR, and it could really be broken down, I also simplified the collect fields and the build field plan code to get rid of to flatten a few data structures and make things a little bit cleaner. But so basically, let's go to the function that calls this function. So this is, for instance, at the root. So the very first thing we do is we run collect fields, which gives us two things. It gives us a group field set, which includes deferred and non-deferred fields, and it also gives us those like defer usages themselves. And then we call a separate function called build field plan, which basically all it does is in Benji's version of his spec edits, he calls this step like partitioning, which is a perfectly good name. But and then so then we have the group field set now contains only the non-deferred fields, and the new group field sets contain the deferred fields. And there's going to be one of these new group field sets for each incremental entry. And so if there's going to be overlapping fields between a couple of different defer usages, those are split out. So like, let's say you have two defers with some overlapping fields, you'd have one non-deferred, and then you'd have three of these new group fields. That's one for the overlapping and one for each of the unique. The next step is we add the new deferred fragments that to the actual defer map, which is passed around. And this is useful for basically because the build field plan is the memoizable version, like the path independent version. And at this point, the defer map is keeping track of like which actual defer everything is associated with. And so we're going to end up passing that around as the spec edits do, following the spec edits. And then we execute normally. The root fields are executed normally according to the operation type. And then if there are deferred fields, we execute them and we pass along those separate group field sets for that we got from the field plan. And so that's what calls the execute deferred group field set function. And let's go to that function itself. That function just takes the new group field set's not a complicated data structure. It just has which defer usages this group field set is associated with, and then we get the actual deferred fragments from that defer map that we've been passing around that correspond to that defer usage set. So that's what the defer map is actually for. And then we create a deferred group field set record. And this record, it's similar to the record that we had in the original version. It holds the deferred fragment records. And it also, we pass along this thing called the executor, which is just a function that it can call. The deferred group field set record constructor is what decides whether to actually defer. And we've spoken about this a couple times, but obviously there are deferred group field sets that don't actually require a new round of deferring. Like let's say those when you're breaking apart common fields and unique fields, different field sets, but they've all already been deferred. And so that's the constructor is what decides whether to kick off that executor immediately or after one tick. But this is basically where we save which deferred fragment records a deferred group field set is actually associated with in the constructor. And we also, while I'm at it, I'll also show you the constructor itself, which decides whether to defer based on a very, very simple heuristic. Basically, if any of the deferred fragment records that this deferred group field set has been issued an ID, that means that it's been released to the client as pending, in which case it can be kicked off immediately. Otherwise, it's kicked off after waiting one tick because we still basically employ early execution. And so this case where the ID will be if we're separating out group fragments that are unique now to this to a couple. Sorry, separating out deferred group field sets that are unique to a deferred fragment, a particular deferred fragment as opposed to shared, that ID field will already have been populated. And so it's basically like keeping a flag on the record that says whether this record has already been released to the client or published as pending to the client. Might be a better term than released. Yeah.
How do you, when you're sending the results to the client and you have so you have like the futures.
Mhm.
Is a future what you're calling a future the same thing as the deferred group field set record? Is it the same
Yes.
object or?
It's this is the type for it. So again, we used to call it an incremental data record. I called it a
Right, okay.
future, yeah, but it's exactly the same thing.
Okay.
And then each of them has a future result, a corresponding future result. And if we go back to the future, I mean this one, it has it has the path, it has the deferred fragment records, and it saves the results. It kicks off the executor whenever it's supposed to, and then it saves the actual result or a promise to that result, depending on whether it was
Yeah.
even if it is kicked off immediately, it might return a promise, and so it's going to return that result. And that result, it's not exactly the same. We have another type for what's actually the incremental entry itself, meaning what's published to the client. But let's see, show you field set result. This has a little bit more information, some of which is not published, right? So this is the result down here. Sorry, the type down here of the result. We pass along, we just copy along from the future itself, the deferred fragment records that this result belongs to, and the path, that is the same. The data is the actual result. And then the futures is any additional, the process is basically
Yeah.
recursive. So it's basically any additional futures. So when we say we're adding the futures to the graph, moving back to that step, we do this for the initial result. And we also do this during the loop. So, and this second step of pruning empty, this is also done in the initial step, and it's also done in the loop. So let's move basically to the.
So when you have the
Yeah.
features, now how do you decide which ones can be sent to the client because an entire deferred fragment is completed?
So how do we decide okay, so that's a great question. So skipping this then for now, where let's say we assume we added the futures to the graph, and now we want to know, now we're processing the ones as they complete. So let's go to the loop. So this loop basically we have the class itself. I retained it as a class because we basically have a queue of completed results that we're basically monitoring. We can monitor Like if a bunch of them complete at the same time, we just look at all of them that are ready to be processed in that tick, and then we wait until some more are ready to be processed. So let's say there's a couple that are ready to be processed, meaning the results have asynchronously or synchronously finished, and now we have to handle them. So we handle them differently depending on whether they're deferred results or stream results. So let's move to the handling function for deferred results. And here it is in all its glory. So we have this check to make sure that it is reconcilable deferred group field set result. And this is basically just a fancy type guard so that we know the data field is not null. Basically, if data is null, then this is true, and we should send it out as um, we should send it out
as an error.
as completed, as an error, as completed. Okay. So otherwise we save all the reconcilable results as, the ones, this is basically, we might be able to not, get away from this step. But just to make TypeScript happy, like I save it again as like a non-error result. Then we add more futures to, do that recursive step. And then this is basically what we want over here. Basically the answer to the question that you asked. Meaning, so then for each of those deferred fragments, we check to make sure that this has an error. Now, I'm not 100% sure on this. I think that this ID could somehow still be could actually be undefined, but I have to think about it more. But leaving that aside for now, we check to make sure that the deferred group field sets on each deferred fragment is equal to the length of the fragment results that we've been, basically pushing. So, right, meaning maybe I should have left the same name of the variable, but as things complete, we push them to this array reconcilable results, which is the same thing as this variable. And if the expected number of results is the same length as the actual results, then we can keep going. Otherwise, we're going to jump out of this loop. And then this is basically if we're in this part of the loop, basically those arrays were at the same length, and then we published an incremental entry. We don't actually have a graph. So like we can draw a fancy diagram where you have a graph that starts at like the set of pending entries. And then basically every time we send one of those pendings, we want to send all the futures with it. And we want to take the future out of the graph, even if it belongs to multiple deferred fragments, some of which haven't been completed. So instead of like creating a separate data structure that is that graph, I basically just reuse the deferred fragments and the deferred group field sets that we already have, instead of like creating a lot of new data structures that are like node entries with children and actually creating the graph in memory. And what that means is that to actually mark a fragment as sent and like totally remove from the graph so it won't be sent twice, we have to set a flag on it to say that sent is equal to true. But that's not, the algorithm itself, meaning the spec edits themselves, don't have that marker because it has the concept of like a graph that we're actually creating. And then basically, so we send all the incremental entries, we send the completed, we delete that record from the ones that are pending, and then this is where we kick off, or I should say, pub release as pending everything that can now be released as pending. Because sometimes we'll have like a nested defer of futures that were returned at the same time from defers that were at different levels of nesting, but at the same actual path position in the result. And so just these very few lines covers that. So this basic rewrite means that there's not we had a lot of like reporting something, we had a lot of pending, we had a lot of extra data structures, but this rewrite really like tightens everything up in that sense also. There's very few data structures that the class has to have. So I'll just go through what they are. Basically, we are adding things to the incremental and completed arrays, and those are like reset every time we go through the loop. The new pending will eventually be turned into the things we release as pending. I called it new pending, even though it's published in the result as pending, because it's actually like, I guess, more accurate. The pending are all the pending ones, and the loop can stop when that's empty. But the new pending is just the thing we publish every single time. This is the loop. This is the array that holds our like queue of things to be processed. This is just a number that we're using as the next ID. And these two variables are what we use to signal that, like, let's say we run out of things to process, we then wait until this promise is triggered. And it's triggered every time we add something to the queue, so that way we can like wake up our queue and keep processing. And then the last one over here is to make sure that we can cancel streams that have been started from like an early execution. We just, every time we ever see a stream during execution, meaning even before we get to the incremental publisher, we add the stream to the cancelable streams array. So basically, we got rid of the incremental publisher. We got rid of the only thing that we add to the execution, the overall execution context, is this cancelable streams bit. And we even could get rid of that. It's only that you can't cancel streams that have been like started early unless you keep track of them somewhere. And so we basically keep track of all the cancelable streams. And I mean by that like a synchronous, like an array that's not a list that's not built off an async iterator. Doesn't make sense to speak of it. If it's built off an iterable and not an async iterable, doesn't make sense to speak of it as being cancelable. So we call it cancelable streams is only the stream records that actually, you could call the return function on. And that's it. Like there's no complicated variables. There's no, in the last version there's like pending and released and completed and all these little helper functions, but we don't have that anymore. We just have
Yeah.
the nice little add futures function that that is pretty darn simple. It just, if it's a deferred group field set record, then it adds that individual record. It knows to release it as pending if its parent is undefined. If its parent is defined, it just attaches it to as a child of whatever its parent is. And then when that parent is completed, we already saw like the section where those children are released. And a stream is even easier. In the stream, we just the streams, even if they're executed early, they won't come up as a future until it's the right time to publish them, because they'll be buried inside this tree of like children. So only at the right time to publish them will they actually be will they actually come up. And so because of that, we can just any stream that's like that stream items record that is ready, we can process. And so those are processed immediately. And so like we don't have to
Yeah.
worry about.
So, I mean, this is great. Definitely a big improvement in understandability for me, at least.
Yeah.
I'm gonna spend some time reviewing it this week, for sure. Um,
Uh, the one there's this the prune empty, I think is like the only second step. It is the only step that we didn't cover, but it's like pretty self-explanatory. It just means that we just skip the ones that are empty, like it says, and it goes fast forwards a little bit to those children. And I think that's basically it. In order to make this work, I had to turn all of our stream items records into basically a linked list,
hmm,
where like meaning a particular stream um, stream items record might have deferred additional deferred group field sets or even additional streams. So everything could, each future result could have additional futures. And um, and basically the first future for a stream result is going to be the next set of stream items. And so therefore, if you have one set of stream items that nulls out, it won't link obviously then to the next set of stream items. And that's why you don't have to worry about filtering in that way either. meaning as soon as one of the stream item results errors, that's it. Anything that was deferred from that or any new streams and even the next stream items is not processed. So that's the basic idea. But then I did want to, but what might throw us a little bit is that, well, let me show you what I don't like about this whole thing. And this was what I was telling you one time, I think, about a lot of appending and a lot of um, excess work with this approach. And it's true in Benji's approach or this approach, whenever filtering, um, uh, you want filtering to emerge naturally, it means every time you go down a level, you have to um, like copy the futures, or I think Benji has a different term for it, but like the incremental metadata that you're saving. So here's an example of the copying that I mean. So this is our execute fields function. Um, and at the end of it, we say that if it contains okay, this is if it doesn't contain a promise. And that's like simpler. But let's say it does contain a promise. So then we have to like do all of this to collect basically each of the keys of that object might contain futures. And we basically want to grab all those futures from the subkeys and make those subkeys no longer GraphQL results and copy all those futures into our new GraphQL result. And that's like very annoying and like a lot of work and not a lot of work, but a lot of lines. I mean, the computer's doing the work, right? But it would certainly be nice if just like we were copying, like every time we encountered an error, we save the error to the execution context or the special context for the deferred group field set or the stream items. It would be nice if we could just append it to like the futures and just keep them as they're going. But as soon as we do that, as soon as we just freely append them to the to like some sort of like context, then we lose the whole idea of filtering, automatically as, when this null bubbling comes up. So in the
Because it's
end,
the same reference to the same array that
yeah,
you'd
it's
be
going to be
editing.
this.
Right.
Yeah,
Yeah.
exactly. So um, what I did is I just gave up a little bit. And so basically off screen, I just added back the last commit um, that I made, and you can see that let's see if we can see it still
You
passed
added the
all the
filtering back?
tests. Yeah, it still passed all the tests, but now we were able to do exactly what I said we couldn't do. We look at the error. Oh, I'm sorry, I'm in the wrong function. It's true what I'm saying, but we're not in the actual function. So here's the execute fields function. And now we have the regular promise for object. And um, whenever there's new deferred group field sets, what we do is we just copy it to the context. But how did we do that? Exactly as you said, um, we added filtering back, but not the exact type of, not the exact same method of filtering, but honestly, it's not that different. What we do now is every time we throw an error and we add the error to the errors array, we also save the path of the error. But not the path that the error started off in, but the path that the error ended up in when it finished bubbling. We actually don't save that before this change, and we don't necessarily publish it. We retain the path of the original error. If there are no errors, you don't have to do any filtering. And if there are errors, you just need to make sure that the path of the future, and even better, the path for the stream, for any of the stream items, doesn't contain any of those error paths. You basically follow it back. In this case, I follow it back all the way to undefined, but you really only have to follow it back to like, let's say we were in some deferred group field set, you only have to follow it back from where that deferred group field set starts. But this basically covers all the cases of filtering um, that we have. If you remember, there was there was a case of filtering that we missed, I think, originally, but this if as far as I understand it, this should basically cover that. That case of filtering that we missed was, I think, when a common set when we had like a unique when we had that case where there was overlapping defers and and I think there was an error in the common portion, so the unique portion shouldn't be published as well. I think this should take care of that um, as well. I have to add in that case, but I think this should take care of that as well because this basically is doing the same thing that null bubbling does automatically, but doing it at the end. And it's a little bit duplicative because the error catching nature of of how we do execution does it automatically, but it means that we don't have to constantly do anything to the futures in terms of collecting them from subfields and sublist items. So that is the last thing that I brought back. And but other yeah, so that's then I'm not sure what to think of that exactly. Basically, I had to give up. I didn't really like how it turned out with all these extra helper functions. So this helps us get rid of them.
Okay. Yeah, good to know. Thanks for going through this.
Yeah,
Um,
it
yeah,
should
I need to spend some time
it should
going through.
parallel the spec edits pretty well, except the idea of the whole event emitter and like keeping track of when exactly we should um, we should execute is not in here because in this implementation, just like the old implementation, we always execute early. So
Okay.
that won't be. All right, but thanks for putting up with me as I went through it. I hope this version is better than the last. If anything, there are some changes in the tests, a little bit in terms of the ordering, a little bit in terms of how things are, like what exact ticks things are ready at. And but I think it's all benign. I'm pretty sure it's all benign. Um, but there are minor changes.
Okay, sounds good. Um, I'll spend some time going through this. Also, Benji suggested that we um, reschedule this meeting because it conflicts with another GraphQL Foundation meeting. Um, I'm thinking that I'm going to move it to right now it's 10 a.m. Eastern time on Mondays. I think I'm going to move it to push it back an hour as he suggested, but also do it on Tuesdays. Um,
Um, Tuesdays is gonna be That's probably yeah, that's probably just as good or bad. Yeah, probably make yeah,
okay.
that's fine. Um better for me is always earlier, but obviously people on the East Coast, only what's doable is doable. I mean like 3 in the morning probably is not the best time for but it works for me. All right. Okay. Anyway, thanks. I think I'm done. Like, sort of like my pens are down for the moment on this, in terms of where I am. So, I know sometimes, we've been able to meet on a weekly basis, but I don't know if you think you'll have time to go over this enough, or you think like when we should meet, when we might want to meet next. But you can just let me know. It doesn't,
Yeah,
I won't bind you with anything. Um,
we'll do. It depends how much time I get to spend with it in the next
exactly.
few days. But
Yeah. Okay. All right.
all right.
All
Yeah.
right.
Thanks, everyone.
Okay. Awesome.
Bye.
Thanks. Bye.